the protection model of the overall JDK. So the XSLT parser, for example, which is embedded in the JDK, is directly taken from a previous Xalan standalone version, which is downloadable from XML Apache org. It is complete, it is highly configurable, and it allows you to customize the functions that may be employed during XSLT. XSLT is extensible style sheet language transformation, and therefore non-final static arrays in the trusted libraries contain objects that are allowed to process data throughout the entire JVM space because they are allowed by the Bootstrap class loader. And then these classes are in an elevated protection domain and therefore may do things other things are not allowed to do. For example, it introduces a class which is allowed to modify data in these packages to insert malicious callbacks, and these callbacks, for example, allow untrusted applets to read data from another applet that is processing XSLT and may allow the untrusted applet to escalate the privileges. It is allowed according to the sandbox, which may be very dangerous, for example in a banking application, and the one applet uses XSLT transformation for some stuff, and another applet introduces a callback, and then the untrusted applet gets all the data which is transformed by the XSLT, which is not really a good idea. So what did they do in 14205? They had this public function, and the public function could be used to define your own this function table, and the function table, it had objects in it which defined your own, which could define own parsing functions, but which is not really allowed in a limited protection domain. So they modified it to private in 14206. In 14206, they adjusted the public table to a private table, and therefore it was not allowed anymore to manipulate the function table of the XSLT parser, and therefore it was not allowed anymore to sniff the data which was transformed by a wrap-off or a combination of the other cases we have seen before. Can include integer overflow, or you check for integer overflow, you check for improper serialization, and you check if you use really only privileged code when it's executed in the all permission protection model. It's not a good idea to have large parts of privileged code. If you adjust your fields to a appropriate scope, you may be safer than before. And if you add security checks to public variables and fields, it may also help you to enforce a security policy. And when you use static non-final fields and static mutable container types, it may also end up in covered channels. So these are the sorts you should be aware of when you introduce third-party components, which may all introduce these problems into your system. So even if your own code is secure, your third-party components may ruin your security concept. So if your vendor of the components you reuse, sometimes, or better, ask them for if they checked their components with find bugs or similar tools, or if you have a closed source vendor, you may ask them a couple of times and then they become aware that you are really interested in secure use of their component and not only in a functional use. A lot of open source projects already include a find bugs report, but as already said, the closed source guys still have to learn from it. So this was the presentation, and after the presentation we do the Q&A, but first let me show you, for example, how the vulnerable object implementation in the JDK may undermine the security concept, for example, of the JBoss application server. Starting routine with, for example, the JDK 14208. And you see it starts here, and the JDK 14208, it has some vulnerable classes. And if I say, for example, invoker upload, and we look at the invoker upload function, the invoker upload method has here, it just invokes servlet and sends a packet to this URL of the JBoss application server, the JMX invoker servlet, for example, and sent it this vulnerable object, for example, the ICC profile there, which is a font description. And if you send it this font description, which you see again is here a serialized object again with this magic number and the SR and the name of the object class, and then here some stuff comes, and I fussed it with some brute forcing, some combination which really harms the JDK. So I sent this manipulated object to the JDK, to the JBoss instance via the servlet upload, and when I send it here, it crashes the application server, because the application server does not, or the JDK under the application server does not check whether this is a valid object or not. So you see it crashes here in this library, and this allows you to do a denial of service attack even on well-coded application like the JBoss application server. How did I say well-coded? Let's say here the JBoss application server also has its problems. For example, if you say to the web space, and for example, if you say here get server XML, you get from the JBoss server the server XML via this particular port, which is not really in the sense of the RFC. So also the JBoss application has some problems. And the last thing I want to show you is about use to trigger database operations. And if I send this JDBC request to an JBoss server, it creates a temporary table, it inserts a fake value, and then redefines some properties in the underlying JDK, sets some debug value, sets this property or defines a alias for property, then sends the internal Java compiler to cmd.exe, and then creates an alias for the compile which uses exe, or previously it used the java c.exe, and I redefined it to cmd.exe. Then I sent it this command, which triggers, for example, the notepad, or it can be used to trigger a netcat or something else. And then the purpose is here, for example, to trick the JBoss application server into code execution set, which is introduced by these vulnerabilities in the org Apache packages, which allows you to override the internal variables in the JDK. And I have here this AND script, and this AND script simply connects to the HITBSecConf2005 database, which is bound on port 1701, and takes this SQL file and executes it. Of course, it needs some binding information from the HSQLDB. So, long speech, short effect. Then we say here and execute it. And now my etc. hosts is shown just by manipulating the internal variables of the JDK, which is lying under the JBoss server. There you see that may undermine your application safety very severe. So these have been the things I want to show you, and there may be questions you want to ask me, and now it's time for it. Yeah? If you inject this SQL into a JBoss server, for example, it can be used to run executables in the with the writes of the JBoss server. So you need to know the internal variables of the JDK. You need to know which kind of JDK level uses these variable names. For example, in JDK 1.5, these have been changed slightly, but with some 1 hour search you find the new names, or just at sun and try it. These are the names then in JDK 1.5. So this is also exploitable via SQL injection. Yeah. Other questions? Yeah. Well, what you really need, is a BCL, the bytecode engineering library, which was coded by some smart guy from the University of Berlin. And he wrote this BCL library, and this BCL libraries allow you to traverse through code, traverse through a class file, traverse into methods, traverse into fields, and then get candidates. And what the Findbugs framework did was define categories and define way to present these things, and defined a common way to automate it. But the BCL does also all the hard work, and you can also do it with. You can write it yourself, but why not use predefined components? Yeah.
The exploit that you mentioned.
Yeah.
Which are those that is runnable on 1.5?
Which is runnable on 1.5, for example. There's one which is not published, or which is not. I can show you here. Let me first definition, and you send it with these one or in hex 1 and 5 JBoss, for example, running, or any Java application accepting remote input. So we start now with Java 1.505, which is quite new, and we send it this package. Oh, this is still running here. Kill this one.